Hola, hola, hola. In this video, you are going to go ahead and learn about exponent laws. Our objective for this video, which should be pretty short, is that students will be able to calculate values with exponents. Please make sure you remember to go ahead and write down the objective for this lesson. Kind of activating your prior knowledge when we have a whole bunch of values multiplied times themselves. Remember, we can shorten this expanded form into exponential form. In your notes, please go ahead and write near here, this is expanded form, and this is exponential form. Please make sure you write that down. So when I have a whole bunch of values multiplied times itself, that's expanded form, and we can simplify this, right, by multiplying it times itself, and then we write an exponent. So this is exponential form. So a couple of things that I want to cover about exponents are that when you multiply numbers with the same base, we add exponents. So here in this example, I have x to the power of 2 times x to the power of 3. Well, notice they have the same exact base, right? Their base value is the same. So what we do is that when the base is the same, we add, sorry, I don't want that in blue. I want to put that, say green. We add the exponents. So notice here I have 3 plus 2. 3 plus 2. Okay? And this gives us x to the 5th. So therefore, x squared times x cubed is x to the 5th. This is the multiplication property of exponents. So just checking this, I want you to kind of think, I'm going to go over this. So 3 to the second power times 3 to the third power. This is, well, without having to multiply all this out, I say, hey, look, the base is exactly the same. The same base. So when I have the same base, I can take the exponents and I add them. So 2 plus 3, and we just kind of saw this in the notes. So I have 3 to the 5th. So that is our answer, 3 to the 5th. For this example, I want you to kind of, I guess, pause the video right now. Can you write down this example on the back of your notes? And I want you to try it. Okay, so hopefully you've tried this example. Again, we have the same base. They're both to the power, or they have the base of 2, and I can add the exponents. So when I multiply numbers with the same base, I add their exponents. So therefore, 2 to the 7th times 2 to the 10th is 2 to the 17th power. The next property I want to talk about is when you divide numbers with the same base, you end up subtracting the exponents. So it works similar. When you multiply, you add the exponents. When you divide with the same base, we subtract the exponents. So here, again, we have the same base. They both have a base of x, and we're dividing these values. And when you divide, you end up subtracting these values. So I'm going to subtract the exponents. So 5 minus 3. Does it matter which one comes first? So what value do I subtract from what value? Well, the numerator, you're going to subtract the denominator from the numerator. Numerator goes in front. So here, x to the 5th divided by x cubed is x to the 5 minus third power, which is x squared. Just some whiteboard problems. Please, again, write this on the back of your notes. You have a blank page back there. So I have 5 to the 6 divided by 5 to the third power. And when I do this, I have the same base. So therefore, I'm going to subtract the powers. The numerator goes first, 6, minus the power in the denominator, which is 3. So 5 to the 6 minus third power is 5 to the third. And this is our answer. Okay, I would like you to go ahead, please write this one down on the back of your notes. Pause the video, I want you to try this. Okay, so hopefully you've had a chance to do this problem now. Again, we have the same base, a base of 7. Therefore, I'm going to take the powers and I'm going to subtract them. The numerator goes first. I subtract the power in the denominator, and 12 minus 8 is 4. So 7 to the 4th power. That's our final answer. So we've talked about multiplying and dividing powers of the same base. Now I want to talk about exponents to the power of 0. This you should know like the back of your hand. Always, always, always. And here's the rule. Exponents to the power of 0, any number except 0, or a variable raised to the power of 0 is always equal to 1. So here I have x to the 0. This is equal to 1, always. That's the property that you need to know right away off the top of your head. Okay, and this is the reason why. So a lot of people say, well, why does it equal 1? Well, the reason is, do you guys agree that you get 0 by subtracting a number by itself, right? So let's say 5 minus 5, that's 0. Do you agree? Okay, so we just learned that if I have a number with the same base and they're dividing, I can subtract the exponents. So what I'm going to do is I'm going to work backwards. I'm going to rewrite that into this form. So the problems we just did, you looked at this and you're like, oh, well, I know that this is this. So this is an exponential form, and now I'm going to expand x to the 5th. I'm going to expand it out, expanded form. Okay, so here I have x times x times x times x times x, okay, divided by x times x times x times x times x. And when I divide all these guys, right, this reduces, this reduces, this reduces, this reduces, this reduces, well, that gives me 1 over 1. So therefore my answer is 1. And this is why x to the 0, or any number, right, it works the same exact way. Instead of x's, these could be 2's, these could be 5's. Anything you want, these always will work out to be x to the 0th power is 1. Okay, so what we're going to do is we're going to write a couple of these examples on the back of your notes. And this should be pretty simplistic. So 6 to the power of 0, well, that is 1. Right? Anything to the power of 0 is 1. Very, very easy, simple. Go ahead, and you don't even have to, well, you can write this down if you want, but I want you to think, what is 120 to the power of 0? Well, it's just 1. It has an exponent of 0. The answer is 1. Very, very simple. The last thing, I believe it's the last thing, that we're going to go ahead and talk about is negative exponents. So what do I do when I have a negative exponent? Well, here I have x to the power of negative 3. Will you agree that negative 3, can we rewrite this as x is 0 minus 3? Okay, and if I have x to the power of 0 minus 3, I can rewrite this with our exponent laws, and I have x to the power of 0 divided by x to the power of 3. Well, this is equal to, anything to the power of 0 is 1. Do you agree? So if I ever have a negative exponent, it's going to turn the whole number into a fraction. So what we do is we take the base and we take the exponent, we put it in the denominator, and the numerator is 1 if you have a coefficient, right? The coefficient here in front of this x is 1. So the 1 stays up here, and then this turns into a 1, okay? If you had, say, 2 times x to the negative 3rd power, this would be equal to 2 over x to the 3rd power. Notice how my variable with the exponent attached goes into the denominator, and that the negative turns into a positive, okay? So let's look at some examples. Here I have 3 to the power of negative 2, and this is going to be 3 to the power of 2, so I change the exponent to a positive, and it's going to go into the denominator. So now I have 1 over 3 to the power of 2. Please go ahead and write down this example on the back of your notes, and I want you to try this. Okay, so hopefully you have paused the video, you've tried this. 2 to the negative 4th. Well, I have a negative exponent, So what I'm going to do is it's going to go into the denominator and it's going to turn positive. So 2 to the 4th, and my numerator is 1. This is the answer. Okay, so those are some exponent laws. And just to bring closure to this lesson, any value to the power of 0 is equal to, so any value, let's say x to the power of 0 is equal to what? Hopefully you said 1. The answer is 1. If you want to write this on the back, you can do that too. You can pause it right now. And lastly, we have this question. It says any value to the power of 1 is equal to, oh, I didn't teach you guys this one. Okay, well we could ignore this. Actually, go ahead and write this in. Anything to the power of 1, I feel like you should know. Anything to the power of 1 is itself. The answer is itself. Okay, please write this example in. I'm surprised that wasn't in there. Okay, with that bell, it is time to conclude this lesson. Our objective was to calculate values with exponents. We have done that. Don't forget, like my video, subscribe. Schwar to the Berg, out.